Hi everyone and welcome back to another episode of Science at Home. So in today's episode, I thought that I would choose an object that's so ordinary and normal that you would never think twice about it. And I'm going to dig into it and figure out what mysteries of science we can find inside. The object I chose today is a simple glass of water. Now you might be wondering, what can you find out about a glass of water that I don't already know? But I'm going to use my logical mind and use lots of thought experiments to figure it out. It's a great approach when you want to be a scientist. So the first thing I notice when I look at this glass of water that seems a bit unusual or a bit hard to explain is the whole outside of the glass is covered in water. See that? The outside of the glass has this covering of water. And why is that? Well, is the water leaking out? How does it get from the inside to the outside? Well, the reason behind this is a little bit more complicated. We have to start thinking about what's in the air around us, yeah? We breathe in air and we breathe out. And we know maybe that air has different gases. It has oxygen, nitrogen, carbon dioxide, but it also has water vapor, yeah? Steam, basically. So there's tiny, tiny little amounts of water or steam floating around in the air all the time. Now you might remember from an earlier episode when we talked about heat and cold that hot objects are just vibrating really fast, yeah? So the air would be jumping around really fast. Cold objects are vibrating slowly. If you slow something down, it cools down. So let's imagine our little molecules of vaporized water or steam that are just bouncing around here in the air. They're moving really, really fast. And suddenly, they bounce against this cold glass of water. Well, the cold glass of water slows them down because it takes their heat. Yeah? So they slow down, and if that water vapor slows down, it goes from gas into liquid. And suddenly, we have drops of water on the edge of the glass. So that's why the water is there. And you could even figure out how humid the air is. Humidity just means how much water is in the air. And some days there's high humidity, some days there's low humidity. You could figure that out by just looking at a glass of water and seeing how much water appears on the outside. Okay, so there's mystery number one. But then mystery number two that I would get to is, okay, we've said that there's all this water mixed up in our air, yeah? And it's bouncing around the place, but how did it get there? The only way we know to make steam, yeah, is to boil water, yeah? Boil it to 100 degrees and it evaporates into steam. So is someone somewhere boiling loads of water? Is this steam boiling hot? Well, that actually comes down to, again, what's happening at the very surface of this glass of water. So we take a close look at the surface of this glass of water and start thinking, well, what's happening there? Is that completely still? Is nothing ever changing? If I left this glass of water here, yeah, and came back tomorrow, would it still be here? It probably would. If I came back in a week, would the water still be here in the glass? If I came back in a year, would the water still be here in the glass? If I came back in 10 years, would the water still be here in the glass? That's a thought experiment. So what you'll find is that the level of water is going to disappear, especially if you leave it outside. The water starts to disappear. And this is, of course, where rain clouds come from. So water can evaporate at less than the boiling temperature. And why is that? Well, if a water molecule can jiggle around fast enough, it will become steam, which is vaporized water. Okay, so we can think at the surface of this water, most of the water molecules are just jiggling around kind of slowly, but occasionally one of them gets just a little bit more energy than the others and he's able to break free and he changes from water into steam. And that's happening all the time in all the rivers and all the lakes and all the water everywhere. And it's happening right here now in this glass. And that's why if you come back in a few months' time, that water will have disappeared. Okay, so that's two different things we're after discussing. So we know that the water forms on the outside because there's water in the air. We know that water can leave the glass and get into the air. But what about something else? Can the opposite happen? Can air get into the water? Do you think air is able to exist down in that water? Well, now we think again about fishes. Yeah, we have fish in the sea and in the rivers. And we know that they're able to breathe through their gills. Now, what do they breathe? We think they're breathing water, but they're not breathing water. They're breathing oxygen, the same as us. So they can only breathe oxygen if oxygen gets into the water. So the same thing happens. Oxygen is able to get enough energy to burrow its way into the water, yeah? Just like the water is able to get enough energy to burrow its way up into the air. So right now in this glass, there's oxygen going diving down into the glass and burrowing its way down. There's water splashing out from the edge. And that's happening all the time. And a little side note, something else I'd like to mention is, you know, if you have hot soup or hot tea or some sort of hot drink, yeah, and you blow on it to cool it down, yeah? Now, why does blowing on something cool it down? We'll be able to tie in what we talked about here. Any ideas? Well, we kind of think that maybe our breath is cold and it's blowing it down. It's not really what's happening. Yeah, there's a little bit of truth to that. It is colder than the liquid, but that's not the main thing. So think again about that water leaving the glass. Yeah, if it gets enough energy, it's able to leave the glass and sit in the air. But there's only so much water that the air can hold. Yeah, think about that. If there was too much air in the water, it would just be water. It would just all fall down. So the air can't hold a lot of water, just a tiny bit. So if you have some hot soup, chances are quite a lot of those little molecules in the soup will have enough energy to leave and become steam. But most of them are going to hang around just above the soup. They'll just hang around here. Now, if you blow on the soup, you move all of that wet air, yeah, all of that air that has all the molecules of water away. And it's replaced with dry air that has very little water molecules. Now suddenly more water molecules can leave the soup, and they can leave it all the time, and that steam leaves the soup and it takes the heat of the soup with it. Okay? So there we go, another little mystery. Do we have any other mysteries we can think about when we're looking at this glass of water? Well, what about this? If I put a pen into the glass of water, and if you look very closely, you'll see that the pen looks like it's bent or broken. Yeah? The pen looks bent or broken. And why is that? We've just put it into water. Why would it bend or break? And when I take it out, it's fine. Put it back in, it seems to bend. Well, the reason for that is water actually causes light to bend. The pen isn't bending, the light is bending. And that's because it slows it down. Now, we'll do a later episode when we'll go into that in a little bit more detail, but you can understand that with your glass of water. You can try that little experiment yourself and see it in your own kitchen. And the last thing I want to talk about with this glass of water is sound. If I ding the glass, I hear a high-pitched sound. If I drink some of the water, I hear an even higher pitched sound. If I drink even more of the water, I hear an even higher pitched sound. So let's fill it up again and hear the difference. Hear that? The sound is changing as we change the level of the liquid. Well, why would the sound change? Why would it go from high pitched to low pitched? Well, that's got to do with how the sound moves through the glass. When there's a lot of water in the glass and we strike it, the vibrations, and sound is a vibration, they have to move the whole way through the glass and back for us to hear them. When there's water in the glass, it slows them down because it takes a lot of energy to vibrate the glass over and back when it's full of water. So that's a low pitched sound. If I drink some of the water, we get a higher pitched sound because the sound can go, it can travel down and back really quickly because it's not affected as much by the water. Who would have thought you'd find so many mysteries of science in a simple glass of water? So what I'd recommend to you guys is to keep your eyes peeled and look around for those little mysteries of science in any sort of object you might see around. Thanks so much for tuning in, guys, and I'm looking forward to seeing you on the next one.